Hello Algebra 2, this is the video lesson for Chapter 5.5, which is about a new concept that you probably haven't learned before called completing the square. This lesson, I expect, will be the last one, the last video that I'll create before the holiday, and so therefore it's going to be the last topic that you're going to be responsible for, I think, before the test that you're going to have right before the holiday. I'll let you know if that changes, but that's my current plan. So completing the square comes up in this guide that I've talked about a few times now in different videos and in class several times. This set of steps, or progression as I keep calling it, of different kinds of techniques you can use to solve a quadratic equation. The top row being the easiest, the bottom row being the most recent one that we've talked about, the quadratic formula, which I've said before is kind of a last resort. It will always work as long as, notice over here we're talking only about solving, not factoring, and as long as the equation is set equal to 0, but as long as those two cases are true, the quadratic formula is always there ready to rescue you in those last resort situations. But it can be a pain to use. And the whole point of completing the square as an alternative is to give you another option if you do find the quadratic formula to be too much of a pain to use. So let's talk about a different kind of scenario where you might end up wanting to use completing the square. Let's compare two different equations. These are very similar to each other, as you notice. The first two terms are the same, x squared minus 8x. The only difference is that third term, negative 5 versus plus 16. But that difference ends up being very important in terms of how hard these are to solve. Again, here's that copy of the steps in the progression. And let's look first at the one on the left here. Well, is it a difference of perfect squares? No, it's not. The first term, admittedly, is perfect square, but this is certainly not. How about, well, none of these first ideas in what I've called here step 1 will apply because that's not a perfect square. So I can go right past all three of these. How about step 2? Is there only an x squared term? Nope, unfortunately, there are two terms, that one and that, both have x in them. So I got to go on to step 3. Can it be factored? Well, you can try to think of it yourself if you want, but you can also just accept it from me. There are no factors of negative 5 that you're going to be able to think of that add up to make negative 8. Well, if it can't be factored, then what we've had to do up until now is resort to the quadratic formula to solve for x. And it's not a terrible situation, but completing the square is there as an option. And notice, by the way, the guide, which is available on my website, by the way, we'll talk about two different scenarios. The first case where a is 1, like this case, 1x squared, and the second where a is not 1, and we'll talk about that in this video as well, like in this case where it's 3x squared. Okay, well, let's compare what happened here with the very similar equation over here. Again, is it a difference of perfect squares? No, because there are three terms. But going down to the next set of options here, square of binomials, well, actually it is. Look, that's a perfect square, as is that. In cases like that, what I taught you is to create two binomials. Don't worry yet about sign, but just take the square of the first and the square root of the first and the square root of the last. X and 4, in other words. Multiply the one by the other, so in other words 4x, double that. Okay, you've got 8x. Well, this does match the absolute value of the middle term. Since it's a negative sign, make those both negative, and those are the factors of the left side, which means x minus 4 times x minus 4 is 0. That's what this is saying, because x minus 4 is the same as this trinomial. Well, if that's true, then x is 4. And this goes so much faster than the quadratic formula that it can be kind of frustrating to have to deal with equations like the one on the left side. You can find yourself wishing, isn't there some alternative to the quadratic formula? Isn't there some way that I can make this solution more like that solution? And in fact, there is, as a matter of fact. In fact, you can make it almost identical to that solution, and that's what the completing the square technique will do for you. The first thing you got to do is move the 5 out of there. That's the problem term in this trinomial. It's the one causing this not to have a shortcut. We move that over, and now we've got this blank space here. In place of that blank space, I'd like to make this left side exactly like the left side of that equation. Well, that means I plug in plus 16. But I can't just arbitrarily add 16 to this one, so I've got to add it to the right side as well. That's fine. So the right side now becomes 21. Okay, so now on my left, I've got the same trinomial that I had over here that I liked and found so easy to solve. Well, that means the left side, I've already done this work, so I won't redo it for you here. The left side is x minus 4 times x minus 4, and the right side's 21. At this point, you might say, great, that's nice, but how did that help me? Well, x minus 4 times x minus 4, remember, is x minus 4 squared. If x minus 4 squared is 21, then I can take the square roots of both sides. I've got x minus 4 equals plus or minus the square root of 21. Now all that's left is to move the 4 over, and I know what x is. X is 4 plus or minus the square root of 21. Now, admittedly, this took several more steps than that, but it's certainly, for many of us, faster and easier than the quadratic formula, and that's why some of us prefer completing the square. I have a guide on my website that goes with this video, and I would suggest that you print it out for yourself and use it as you do the rest of the homework tonight. But let me walk you through this example that they have here, just so this is all clear. Step one, as I say, is to rewrite the equation you have in standard form if it's not already in standard form. So this one's not. I move everything together and I put it squared term first, x term second, and constant term third. Now I've got a standard form equation. Okay? Step two is to make sure it can't be factored. If it can, like I said here, don't waste your time with completing their square. There are faster ways. Well, there are not any factors, trust me, of 6 that add up to make negative 8. So that's not going to work. So I'm going to keep this equation here, x squared minus 8x plus 6. Here's that equation, but the problem, as I say, the problem term is this third term. Let's get it out of there. Let's move it to the other side. Now I've got a blank space here. Now, what do I put in here? Well, let's make this as simple as possible. Really what you're doing, what you're putting here, you're splitting this coefficient here, negative 8, in half and doubling it. What's half of negative 8? Negative 4. What's that doubled? That's 16. So you want plus 16 in here. If you're going to put plus 16 here, don't forget you're going to have to put it there. Okay, so that's what I have here. I've got x squared minus 8x plus 16, but I've added that to both sides. Great. On the right side now, negative 6 plus 16 make 10. So on the left, I've got a perfect square trinomial, and on the right, I've got 10. Well, let's factor that perfect square trinomial on the left. Just remember, actually, why don't I go back? The factors of this are going to be square root of this times square root of that doubled. Or an easier way to say it is, it's going to be, the right side is going to be half of this. It's going to be minus 4. And that's what this is saying. It becomes, like I said, minus 4. So I've got x minus 4 in parens squared equals what I had already on the right, 10. Now I'm going to take the square roots of both sides. X minus 4 then is plus or minus the square root of 10. And I clean this up and I'm done. X is equal to 4 plus or minus the square root of 10. Here's a similar one for you to try yourself. Go ahead and work it through. Hit the pause button. When you come back, I'll show you the right answer. Okay, I'm going to assume that you did that. The first step was to get it all together in standard form, so I've rewritten it this way. Second is to make sure, as it says here, that it can't be factored. Well, there really aren't any factors of negative 17 other than 1 and negative 17 or negative 1 and 17. Neither of them adds up to 10, so I'm safe there. So I go on to the next side. I've got my equation now. I'm going to move the negative 17 over. Now I've got that gap. I'm going to split 10 in half and square it. So that's 25. So now I've got x squared plus 10x plus 25. I've got to put that 25 on the other side as well. So there it is here on the other side. or in other words, the right side is now 42. So I've got x squared plus 10x plus 25 equals 42. Now I can factor this perfect square trinomial, and it's going to turn out to be x plus 5 in paren squared is equal to 42, which means, of course, that x plus 5 itself is plus or minus the square root of 42. I move the 5 over, I'm done. That's the answer right here that you should have come up with for the example I gave you. Negative 5 plus or minus the square root of 42. If you didn't, or are confused about it, come into class with questions. We're going to talk this through in class. The other side of that guide explains what to do when the x squared term is not 1. And it's really actually a pretty simple process. All I'm going to do is get rid of that 2 in front. How? By dividing everything by 2. If I do that, then I've got, instead of 2x squared, I've got x squared. Instead of 8x, I've got 4x. Instead of minus 6, I've got minus 3. And 0 divided by 2, after all, is still 0. Now I've got something that I can apply the front side of this guide to. I can essentially walk it through from step 2 just like I had on the previous page. That's what you ought to do, but I've given you here one to practice. So again, hit the pause button, and when you come back, I'll walk you through this answer. Okay, I'm going to assume that you did that. I'm going to assume that you divided everything by negative 3. And now you've got x squared minus 2x, x squared minus 2x plus 11 equals 0. You've created a gap for yourself by moving the 11 over. You split that in half, got negative 1, squared it, got positive 1. So the left half is x squared minus 2x plus 1, and the right half is negative 11 plus 1, or in other words, negative 10. I have not finished this problem for you in this video. This is as far as I've gone with this problem. But on the next slide, I do have another similar question to this one. Here it is. So what I'd like you to do one last time is hit the pause button, come back, and when you come back, I'm simply going to show you the answer to this question, and that'll be it for the video. Okay, I'm going to assume that you did that. And here are all the steps that I used to find the solution, what x is for this equation here. X turns out to be negative 3 plus or minus the square root of 11. All the steps I used are here written out. So hit the pause button and study them if you need to. If you have any questions about how I solved this, don't hesitate to come in with those questions. And the rest of your homework for tonight is just to do these 6 problems on page 287. So go ahead and work through those, bring those in with you to class. We'll go over those. We'll see if you have any questions, and if you don't, we'll practice some more of this. And that's it for this lesson.